Are we live? Are we streaming? Yes, we are indeed. Okay, people, welcome back. Let's do the YouTube stuff. How are you guys? Welcome back to my YouTube channel. Alright, cool. So, cool. Back to my project here, my little robot. So, I still don't know what I'm doing. I mean, I know what I'm doing, but as in, I haven't. Uh, I haven't completed or I don't have basically I have no plan. I'm just kind of like freestyling it. So what I did yesterday, I extended the as you can see here, I extended the arms on the on this little bot here. As you can see, we made them a little bit bigger. But I'm having an issue here. I'm having a problem because I could easily fix it, but I wanted to do. No, actually, can I fix it? Yeah, I can fix it. So what I can do is just basically, so the problem that I'm having, as you can see on the code section here, let's go to the code section, and you'll see that so Arduino blah blah blah, and here I've created forget anything that I commented out because yeah, I'm not using that. So these were as I'm trying around. I'm trying out um, new different possibilities of getting this to work. I just comment out the instead of deleting because I might use it and it saves me time just typing. So I'll just comment out. And if I need it again, I'll just delete the slashes here and like this, for example. Boom. So if we need it now, all right, cool. So boom, boom, boom. So now I have like I was saying, I I made I created three for loops, no, five for loops. Sorry, and the first for loop is for the first motor, the right one. And as you can see, these are uh half uh half a clock cycle servo motors. That means they only go from 0 to 180 degrees. They can't go 360. Therefore, uh, and we, as you can see, the way I position my servos, they kind of mirroring each other. So this one is going 0 to 180 this way, or sorry, 0 to 180 this way, and this one is going sorry about a little technical. Fucking should have recorded this. Stupid. Ah. Alright, cool. Let's just try to record for a bit. Sorry about the camera moving. Like I was moaning about the setup yesterday night, but I'll get it fixed soon. Alright, cool. So we're back here with this. I should play a little music in the background, or that might get me distracted again. Alright, cool. Back. Let's be serious. Alright, so like I said, the problem. No, actually, let me start again. This recording because I was doing some stupidness. Back here. Cool. So I was saying, the problem that I'm having at the moment, coding the servos, programming the servos, is because the way that I position the servos, uh, it's the best position. No, what am I trying to say? Okay, I forget what I was going to say. So what I did here, that both the servo motors, like I was saying earlier, they go from 0 to 180. So the way I position them, these two are mirroring each other. So the problem is that's this or one of the servos is flipped. So they're not. If we want to use, see these two servos, no, actually, Is that what I need to do? Oh yeah, oh yeah. Fuck it, let's do that. That's easier, man, than coding the whole. I reckon I'm just gonna do that. So either we just flip this servo motor this way horizontally, 90 degrees horizontally, so that it can we won't have to use a different for loop. It could be just this and this going from 0 to 180 degrees at the same time, or whatever this one does, this one does. But at the moment, we have two different for loops because this one has to go 0 to 80 and this one has to go from 180 to 0 in order to be synced, or to mirror each other. So that's the problem I'm having. I'm sure there's a way of programming it differently, or just a different way of coding this. So now I don't know whether I think the easiest way is to just flip this and then yeah, it's simple. But I like problems and I like challenges, so I'm gonna try program it instead of just flipping this motor. And so what I was so now the thing is I'm having a problem because I'm using two for loops. So what the computer is doing, so that's the loop. That's uh our main program kind of main loop. That's the repetitive cycle we want the motor to execute. That's not the word. See, my problem is by the time I use the word, I forgot what I was actually trying to say. Then I don't know what word I'm looking for. Um, yeah, that's a very big problem. So please bear with me. Okay, so servo motors. Back to the servo. So like I said, I was using for loops. What the computer is doing now, it's going from so what it does, it executes this loop. So now the first motor, no, this one, uh, position number 1 and front left servo, front left, yeah, front left servo, or front right. This is the front right. This is the front left. So front left servo, this is our number 1. Should have been number 2, but yeah. It's going from it starts at 45 degrees. So when we boot up our bot, all the positions, servo positions, are initialized at 0 degrees. So when we plug it, it goes to 0 degrees. Then the computer, boom, boom, boom. So yeah, we go to 0 degrees. Once obviously here we're attaching our servo motors. So what we're doing here, so we're just telling the computer now. Here we imported the. Wait, what's happened there? Yeah. So what we did here, we imported or included the servo library. That means we're helping out Arduino here by writing less code to program the servos, because the servo function knows already what we're dealing with. We have servo motors, they go from 0 to 80, it knows everything about them because people wrote the code to make it easier for us, for like noobs like us. So thanks to them, we have this function that we can use, and we don't need to write a lot of code. All we need to do is just type servo to call the function, like the servo.h. So imagine this as a folder we just imported, and this is a file, one of the files in the folder that allows us to create a variable to store in our chip, to say that this variable, it's a servo motor variable. So the Arduino would then import some of the codes, or like instead of writing for example, for like an LED, if we don't bring, if we need to use an LED light, we don't need to bring any libraries, because it's a straightforward connection and no, not connection, program. Program, is that the word I need to use? Anyway, so what basically it does with LED lights, you plug an LED here, let's say, you plug it somewhere, and you say, if you want the LED to be on, you just come here, you just declare your pin. For example, you come to the setup here. No, for here, you need to create a variable at the beginning along like with these. It doesn't matter as long as it's above the void, above the setup. So you can say LED pin. That's our new. We're gonna use one pin for LED, so we'll call it LED pin. Then you give it 13, for example. Pin number 13 now will allow us to use a light. So if we come here, connect a light, little LED. I made a video of these. I'm not sure if you guys have seen it, if it's posted. Like, my videos are such a mess. I'll record, I don't know which one's good. Some are shit, some are really good. So therefore, what we're gonna do here, we're gonna connect, like in our, we'll always need a little resistor for our LEDs. I saw an LED light here somewhere. Alright, let's grab a new one. Alright, we're gonna get a blue one. I like blue LEDs. Like a blue tin. Let's get a blue tin. Use them, light them. So you can, so no. Alright, so boom. What pin are we using actually? Let's do this and save this. And then, but it doesn't really make any sense because I can't reach. I was trying to save wires. Yeah, we could do that. I guess that's 13, innit? Isn't it the pin 13? Alright, so we can't pin. So, oh, yeah, that's pin 13. Boom. Give pin 13. Alright. Now, our Arduino should be our LED. Why am I showing you LED? Oh, just to say that we don't need any function. So all we need to do to program an LED light, so now our LED is connected. So we have the little pin connected to ground as always. It's a ground pin, and then the long pin is the plus, positive, or voltage, whatever you want to call it. It's connected to a resistor, a 220 ohms resistor that prevents our LED from getting blown up by a little surcharge in power or in the current. So we're using a resistor straight onto pin 13. Okay, so it's a straightforward connection. Then we come here, type LED pin 13. So we're telling the computer that LED pin, this name here, we gave it 13. So now the computer knows when it basically, it will refer to LED pin as the variable 13 or number 13. So all it knows so far is that LED pin is 13 or equals 13. What happened here? No space, for fuck's sake. I'm tired of this fucking shit. Can't do nothing. Let me delete this video. Delete this shit. Delete this. I don't care. Delete this. I don't care. I'll just save this one, the one I'm using. That's it. This forehead guy, man. I like the forehead, dude. Have you man seen a guy with a forehead that got arrested for, I don't know what he's done, but I saw him on I think it was on Facebook. The guy's got plenty of forehead, man. Bless him. Fucking some Robocop shit, man. That's bad, man. I'm going to hell for this one. I shouldn't be talking shit about a beautiful people. Uh, boom. Alright, so we're back. We're back at this. So I stopped at the LED. So I said LED pin. Now we told the computer that LED pin is 13. So all the computer knows, it has two variables: LED pin and number 13. And now LED pin equals 13. So far, that's what the computer knows. So we come here to the setup. So we call this function, it's called the or command pin mode. Sorry about so we call pin mode. Okay, again it's orange, so that's a command. So a function. Yeah, call it fuck it, whatever it's called. Pin mode. So this is what you do. So pin mode is always followed by two brackets. Not brackets. Alright, so we're gonna where is pin mode? Yeah. We're gonna tell the computer that now we're in pin mode. So we're telling the computer that we have a pin. We're in pin mode. We need to tell you that there's a pin that you need to connect. We need to let you know about a pin that we're gonna be using. So the computer already knows LED pin equals to 13. So we don't need to say we don't need to we don't need to mention 13 again. Now at this line here, the computer knows as soon as it goes past this line, it knows now LED pin equals to 13. Then, so here, we're going to tell the computer, so far, before this line, the computer still doesn't know that LED pin is connected to pin 13. But now we need to connect the LED pin, or we need to tell the computer that our LED pin will be, we'll give it pin mode, so it will be an output. No, it will be, so we'll give it LED, we'll have to name it, not name it, just call it. So pin mode, we're telling pin mode that we're using LED pin. That's the name of the LED, so equals 13. So we're using pin 13 by writing LED pin. Now our computer knows it's pin 13. Boom. Next, what we do, come here, and you have to tell the computer what to do with it. Give it, is it an output or is it an input? Are you going to be sending information to it, or you're going to be extracting information from it, or electricity or whatever? So far, so now we've told the computer that our LED pin is number 13, and that now we're telling the computer that our LED pin 13 is an output. Cool. Boom. Close this. So now the computer knows that pin 13 pin 13 is the output, right? But it doesn't know when to turn it on. So I think by default it's off, or maybe 13, because it's the built-in LED for the Arduino, for the microcontroller. So therefore it might blink. I don't know. But anyway, so far now we've told the computer that we have a pin. Yeah, it's an LED. We call it LED for us as a reference. The computer doesn't care what you write here. It's just good for you to it's like when you're dealing with a lot of pins or a lot of numbers, it's good that you can be as precise as possible, and try and make it short, you know? For example, yeah, just keep it short, basically. Ah, for fuck's sake, I'm gonna have to stop recording. One second, let me take this phone call. Ah, for fuck's sake, you can't do nothing, man.